Hello there. Today I will show you how to design and simulate an up-down binary counter, and I will be using the Autodesk Circuits program. You can type circuits.io, and all you need is just create a username and a password, and that's all. It's a free program, okay? And I have a schematic diagram and other information here in my website. This is my website, fwdskillzone.com, and this is where I keep most of my educational documents. So today we will be designing an up-down counter that can count from 0 to 15 in a binary. Okay, so we will be using these LED lights and then this 7-segment display. Okay, all we need is 2 resistors, 1 capacitor, a 5 timer, 74193 binary counter, a 7447 7-segment decoder, and a 7-segment display. So we will build this circuit and we'll simulate it. Okay, so the intent of this presentation is just to see how we can count in a binary from 0 to 15. 0 in binary, in 4-bit binary, is 0, 0, 0, and then 15 is 1, 1, 1, 1. So this is counting from 0 to 15, and then we're going to modify it to count from 15 down to 0. Okay, so let's go back to the Autodesk Circuits simulator, and here I have opened a breadboard, just a regular breadboard, and all we need is to bring the components. To bring the components, you go to here, component, and then find whatever components you need. Okay, for a beginner they have enough components here. Okay, let's go back to the schematics and see what we need. Okay, we need 2 resistors. That's the first thing. Okay, let's go get resistor, and then I'm gonna put this resistor just like this. Okay, because if you see the diagram, the one leg of the resistor is tapped to the VCC, to the voltage, right? Okay, and then I need another resistor. Okay, I'm gonna get another resistor and I'm gonna just put her here. Okay, and then we need a capacitor. Okay, before we bring a capacitor, let me show you something. Okay, so now we have these 2 capacitors, 2 resistors, but we have to determine their value, right? On the schematics, it tells you that the first one is 10 kilo ohm and the second one is 100 kilo ohm, so we have to set it accordingly. So when you click this, you will get this dialog box and just change the value 10 and the unit. Okay, I need a kilo ohm, so I'll get that one, and then you click the next resistor and you will change the value to 100. Okay, now as you see it, the color changed. These colors, they're representing the resistance value. Okay, and then we need what do you say, capacitor? Yeah, we need capacitor, right? So let me go get capacitor here. Okay, so this is not polarized, but if you're getting a polarized capacitor, you have to make sure which leg is negative and which leg is positive. Okay, you go to the schematics and you see the negative side is connected to the ground. Okay, so I'm gonna put this capacitor here and I'll use this rotate to rotate the capacitor like this. Okay, and then I'm gonna put it like this, and the other leg was connected to a ground, right? If you remember on the picture, it's connected to a ground. Okay, I'm going to change this color, the wire color, to black. Okay, so we finished this side. Let me go back to the schematics, and now we gotta get a 5 timer and then these other components. Okay, let's go to component and bring all the remaining components. Okay, where is 5 timer? Here we go. You put the 5 timer here, and I think 7-segment decoder. Okay, yeah, I'm gonna use 7-segment decoder here, and then we need a 7493 or 74193. I don't think they have 74193, but they should have, yeah, 7493, 4-bit binary counter. Okay, I need my counter. Okay, and then I need 7-segment display. Okay, there are two types of 7-segment display. One of them is anode, a common anode, and the other one is common cathode. Okay, so if your 7-segment display is a common cathode, make sure you connect this common point to a ground. If it's a common anode, then you'll connect this common point to a positive line, to the positive line here. Okay, so now let me rotate this guy so that I can line up the IC with the breadboard. Okay, now I'm good. I can just put it somewhere. Okay, I got all, see, I got all my components lined up. Okay, later on I'll bring LEDs. Okay, and then next let's connect this point to the discharge line. Okay, and I'm going to show you how you can do that. When you hover over on these legs, it will read its trigger, output, blah blah. So you can hover over on the IC and it will read these out at these points. Okay, so now this is ground, right? So I can tap this line to ground and change the color black, and this is VCC. Okay, so I have to give them power VCC. Okay, power and ground connected to this IC. Now I'm gonna tap from this line and give it to discharge. Okay, so tap from here and hover over here, discharge, right? Okay, that's what I'm looking for, and then change the color to whatever color you wanted. Okay, and then we're gonna tap from this point between the resistor and the capacitor, and we give it to the discharge and threshold. Okay, from this point let me hover over trigger. Did I say trigger? Yeah, oh, trigger, yeah, okay. So I'm gonna give it to trigger. Let me change to some other color, and then the same output will be shorted with threshold. Okay, where is threshold? Threshold is here, so this and this will be kind of like shorted, this and threshold like this. Okay, I'm gonna give it same color, same color with this one so that I know it's shorted. Okay, so I've done this, I've done this, I've done this. All I need is reset will be connected to power. Okay, where is reset? Reset, okay, reset. I can go from here to power or cross it like this, and then it will be connected to this ground power line. Okay, let me change it to red so that I know that these are shorted. Okay, in the same fashion I will be connecting all this. I'll pause the video because it's going to take me longer time, and I will connect all these outputs in the same pattern, and I'll connect it to this LED. Before I do that, let me show you these LEDs. Okay, let's go get the LEDs. Okay, let's grab LED. Okay, where is LED? LED. Okay, LED. Okay, so I'm gonna put it somewhere here, and I'm going to show you. So this short side is a cathode, so you have to connect this to a negative, and this anode is positive, or usually the output of the IC, because you're going to be using the output of this 7493. So what we can do is I'm going to push it somewhere here because my ground line is here. I'm going to connect ground like this. Okay, so we need 4 because we're going to be counting to 4 bits, right? So we need 4 LEDs. Okay, when the LED is on, it will be representing 1. When LED is off, it will be representing 0. So we need 4 LEDs. So you can use just a Windows shortcut, Control C, Control V to make copy paste. All right. And the other thing, before I pause the video, I'm going to tell you something. You have to connect the other leg to a resistor. Let's go back to the diagram. You see, it's connected to a resistor. This side is in negative. We already connected it to the ground, right? We already finished this part. So this leg has to be connected with the resistor. Otherwise, you might burn the LED. Okay. And then what is the value that I have used? It's 330 ohm. Okay, so I'm gonna get resistor. No. Let me go get resistor and connect it to here. Okay, and then as usual you click here and you give it value 330, but now not kilo ohm but ohm, 330 ohm. So you can copy this and paste it. Control V to paste, Control V, Control C to copy, and Control V to paste. That's common in any Windows application. All right. From this point on, I'm gonna pause the video and do all the other connections, and then we will do the simulation together. Okay, I have almost completed the connection. I connected the output from the 7493 to each individual LED. This is the most significant bit, and this is the least significant bit. And then I also just tapped the same output to a 4511 7-segment decoder, and then from the 7-segment decoder, again I have used resistors to the 7-segment. If you don't use a resistor, there might be a possibility of burning these lamps. Okay, if you see the schematics, there are resistors, so you have to follow the design. Okay, all right. That's all pretty much. Let's go ahead and run. Oh no, before we run it, we need a power source, right? We need a 5-volt power source. So I'm gonna grab a battery maybe like yeah, this should be enough for a battery, and then I need to rotate this guy like this. Okay, so each battery has a 1.5 volt, so 1.5 times 4 is 6 volt. That should be enough. Okay, and then you hover over here and it will tell you negative, so I'm gonna connect it to the negative side, and always I put negative on black. And then this is positive, I'm gonna connect it to the positive side of the breadboard, and I always give red for positive. And the other thing, this breadboard is not connected on this junction. From this point to this point is open. Okay, whatever you give here, this power and this ground is supplying only these lines. So this side has ground, this side has a power, so the other side needs power and this side needs ground, so I have to like cross connect this. Like, let me do like this. Okay, that's ground. Okay, now this side got ground, but this side doesn't have a power, so I have to tap a power from here. Tap power from here, and okay, and then give it red. Okay, all right, now we are good to go. Okay, all right, so the next step is simulating. So when we simulate, what's gonna happen is, first all the LED lights will be 0. You know what, let me cut this, let me copy this. Oh, sorry, let me copy this sequence at this sequence copy. I have a what you call an image snapping tool. Okay, all right, and then I'm gonna bring it here. Okay, once I started the simulation, I'll bring this one. Okay, so let's go ahead and start the simulation. Okay, simulate. Okay, and then I'm gonna bring this guy. Okay, now 1. Okay, 1 2 1 0 1 1 1 0 0 1 0 0 1 1 1 0. I can't count, it's so fast, but anyhow it's counting like that. Okay, and also the LED is also, let me stop this one more time, and then let's see the LED part here. So 0 1 2 3 4 5 6, and it will count only from 0 to 9 because this 4511 doesn't have the hexadecimal decoding capability, so this counts only from 0 to 9, while this one counts from 0 to 9. This one was counting from 0 to 15. Start simulation. Okay, 1 2 3 4 5 6 7 8 9 9 10 11 12 13 14 15. Okay, so let's stop this simulation, and now we'll go to the next one. The next one is we're gonna trick this circuit to count up to whatever we wanted. Let's say the design is saying mod 6. Okay, mod 6 means from 0 to 5. So if I wanted to count from 0 to 5, which means I need 6 bits, so I'm going to tap the 6 bit, which is 0 1 1 0 is 6. So I'm going to tap from here and from here and give it to the AND gate, and the output will be tapped to the memory. By the way, this circuit is 74, this IC is 74193. However, here we're using 7493, it's not 193, so it's a little bit different. But anyhow, let's go get AND gate. AND gate should be somewhere here. Okay, this is AND gate, yeah, AND gate. Okay, oh man, I don't have space. Okay, I'm gonna put it outside. Okay, so the same thing, oh sorry, the same thing, you hover over, this one is VCC and this one is ground, so immediately I'm gonna give this power, and this guy is ground, right? So I'm gonna give it to ground, and I make sure I change the color so that I know. Okay, and then AND gate, you can Google this what you call them datasheet. Okay, you can Google the datasheet I have here for the 5-5 timer, for the 47, for the 193. So if you want to see how AND gates looks like, you can Google it and you can see, but it's easy. AND gate is easy. You have two inputs and one output. See, for B, for A, for Y. This is one AND gate. Here 3B, 3A, 3Y, another AND gate. So I'm going to use these three. So as we said it, we wanted to count up to 5. Up to 5 means mod 6. We need from 0 to 5, which are 6 bits, right? I mean 6 numbers. So to count fix, it's 0, 1, 1, 0. That's 6. So I'm going to tap from this one and from this one. So from somewhere here, tap and give it to the AND gate, to one of the input. And from here, tap and give it to the next AND gate. And then the output, now, if you see this, the design, it will tell you to put it in memory, right? But it's 193. Ours doesn't have a single memory. It's a different one. It's like you have memory one, MR1 and MR2. Okay, so originally MR1 and MR2, they were tapped to the ground. So all I need to do is take this ground out, delete, and then I will give one of this leg the output of this AND gate. Okay, change this color, maybe gray. Okay, I think it looks good. Let's test. You click start simulation and it should count from 0 to 5. 0, 1, 2, 3, 4, 5. Should go to 0. 0. We did it. Okay, that's good. All right, now let's stop this and let's see what's gonna happen if I grab this leg and put it here. Okay, this is 0, 1, 0, 1. Okay, so let's start the simulation. 2, 3, 4, 0. That's correct. Okay. Okay, let's say we wanted it to count up to 10, up to 9. Okay, we don't have 10 on the simulator, so if we want to go to 9, that means it's a mod 10, so it should be 1010. So this guy has to go here, 1010. Okay, this should count up to 8. 0, 1, 2, 3, 4, 5, 6, 7, 8, yeah, that 9, 0. Okay, let's run it one more time because I have observed something. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And then it's gonna go faster. Yeah, something is not okay. Definitely this is from the capacitor, so it shouldn't go fast like this. Let's go to the diagram and see. Okay, 10 kilo ohm, 100 kilo ohm, and 10 microfarad. Okay, this is 10 kilo ohm, that's good. 100 kilo ohm, that's good. And this guy up 3 microfarad. Oh, it should be 10 microfarad. Okay, so this guy has to be 10 microfarad. All right, and now let's try the simulation again. 0, 1, 2, 3, 4. Keep going, keep going, keep going, man. By the way, you can increase or decrease the speed by changing the value of the capacitor. Okay, 9, 0. Now it should continue with this speed. 1, 2. Yes, okay, that's good. 3, 4, 5. That's good. Okay, now let's see one more thing. Okay, as I told you, this IC is a 193. It's a little bit different from the 93. So 93 has this CPO and a CP1 um, legs. Okay, so let's see. Let's put the 55 timer output to the CP1. Okay, I'm gonna put it here, and this one here, I just switched the position. Okay, so what's gonna happen is it should count 0 2 4 6 8. 0 2 4 6 8. Okay, let's try it. 0 2 4. Okay, 6 8, and then back to 0. Yeah, because we tapped it from 1 0 1 0. Okay, should go to 9. Oh, okay, in this case it counts 2 4 6 8. Okay, that's correct. That's absolutely correct. This is all for today. I hope you have enjoyed the video. I hope you like the circuit, the counter circuits. For more information, please visit my website, fwdskillzone.com. Thank you, and you all have a wonderful day.